Okay guys, we are doing 10A part 2 notes, and this is example number 4. Just like we've been doing in problems 1 through 3, we're setting up our trig ratios. Okay, we use this SOHCAHTOA to remind us what our trig ratios are. And when we're asked to give those trig ratios, we want to give sine of theta, cosine of theta, tan of theta, or tangent of theta, okay? So, again, like we have before, we're always going to label our triangle first because everything in trig is with respect to a specific angle. So we want to make sure that we are identifying the right angle and then labeling that triangle correctly. That's a critical step. The first one we're always going to do in trig is our hypotenuse. It's opposite that 90-degree angle. Guys, sometimes it's blue on the inside, sometimes it's not. So on our examples, I wanted to show you that it can be blue on the inside, but sometimes it's just that square marking, okay? But whenever you have that long diagonal, we just mark that with H for hypotenuse. Now, theta is going to be in between the hypotenuse and one of the other sides, okay? And that side that's touching theta, you know, we call that the adjacent side, and we label that with an A. The one that's left, not touching theta, we label with an O for opposite. And just like on example number 3, look at this. We're missing a side length, okay? So we're going to just use that wonderful formula from the Pythagorean Theorem, a squared plus b squared equals c squared. Now that missing side we labeled with x, okay? And again, a squared and b squared, those are legs, right? C squared, is always the hypotenuse squared, okay? So this is another way to think about that Pythagorean Theorem formula, so that when you actually plug numbers in, our legs are those sides that are making that right angle. So we can plug those numbers in. We've got a 12 squared plus a 5 squared, and that's going to equal our hypotenuse squared, which we don't have a length for, so we'll use that x squared, because that's how our formula is. Now we'll just go to our handy dandy calculator and we'll square those numbers. Of course, 12 squared is 144. I pull up the calculator, guys. I know these in my mind. The reason I'm pulling up the calculator is because sometimes when you're learning a new principle in math, and you are just relying on your memory, unless you feel rock solid about your multiplication or your squares or your square roots, I just want you to double check with your calculator. That way, your brain can focus on the new math. Now, of course, I'd love for you guys to be rock solid about all your arithmetic, and you'll get that way as you double check yourself with your calculator, okay? Now we're going to add that 144. Again, I'm just showing you guys that it is not a bad thing to go and do the arithmetic on your calculator, right? So when we add these together, we're going to get 169 equals, we're still at x squared. If it helps you guys, you can switch these places. So you have x squared equals 169. You can just do that. It doesn't matter which side is which. And now in order to get x, we need to take the square root of x squared. And when we do that, again, you're going to go to your calculator. You're going to hit the square root. And if you get an even number, use it, guys. Square root of x squared is x. Square root of 169 is 13. And then we'll fill that in up here. So now instead of that side being an x, it's a 13. Sorry, I think I got something stuck in my throat here, so I apologize for the little cough. Now we're going to set up our trig ratios. We know sine is opposite over hypotenuse. Our opposites say, no problem, we've got them all labeled over our hypotenuse, which we got from Working our Pythagorean theorem, our cosine of theta is adjacent over hypotenuse. Our adjacent's 12, hypotenuse is 13. Tan of theta, opposite over adjacent, 5 over 12. And that's it, guys. Thanks so much for watching.